Good morning, grade 6. How are you, my dear students? Today, inshallah, we will start a new unit, Unit 14, Ratio and Proportion, Topic 14.1, Simplifying Ratio. You can follow this on your course book, page 137. Our objectives today is use ratio notation, simplifying ratios, and divide a quantity into two parts in a given ratio. Now, I want from you to compare the number of red beads to the yellow beads. Now, how we will compare the red beads to the yellow beads? First, you have to know how many red beads we have. The number of red beads equals 2 and the number of yellow beads equals 6. If we compare red beads to yellow beads, we get how much? Yes, we have 2 red beads to 6 yellow beads. So now we are making comparison between the yellow beads and the red beads. What do we call a comparison between two or more quantities? Yes, we call it ratio. What we call it? We call it ratio. We just found the ratio of red beads to yellow beads. Is the ratio of yellow beads to red beads the same? What do you think? Do you think that the ratio for red to yellow same is the ratio to yellow to red? What do you think? Yes, no. When we write a ratio, orders matters. So our aims today is to understand what is a ratio. To understand what is the meaning of ratio, let's solve this example. We've got some apples here and some oranges. And what I want to think about is what is the ratio of apples to oranges. To clarify what we are even talking about, a ratio is giving us the relationship between quantities of two different things. So, there is a couple of ways that we can specify this. We can literally count the number of apples. 1, 2, 3, 4, 5, 6. And we can say ratio is going to be 6, and then how many oranges do we have? Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the ratio of apples to oranges is 6 to 9. And we can write this in different way. We can use the column, so we can write it 6 to 9. But you would still read the ratio as being 6 to 9. But we don't have to just satisfy with this, because one way to think about ratios, especially if we are thinking about apples to orange, is how many apples do we have for a certain numbers of oranges. When you think about it that way, we can actually reduce these numbers, as you might have already thought about both. 6 and 9 are divisible by 3. So, just like we reduce a fraction, we can also reduce ratios. So if we divide 6 and 9 both by 3, what we will get? Yes, we will get 2 to 3. So 6 divided by 3 equal 2, 9 divided by 3 equal 3. So the ratio of apples to orange is 2 to 3. Or if we want to use this notation, we will say 2:3. Now at this. We divide each of these groups into 3. So one way to think about it, so if you divide this whole total into 3 groups, 1, 2, 3 groups, you'll see that in each of these groups, for every 2 apples, we have 3 orange. So once again, the ratio of apples to oranges. For every 2 apples, we have 3 oranges. Now let's solve this example also. How many basketballs to footballs are there? What we have to do first? First, you have to count how many basketballs. 1, 2, 3, 4. And how many footballs? 1, 2, 3, 4, 5, 6. So for every 4 basketballs, there are 6 footballs. So the ratio is 4 to 6. What are some other ways we can write the ratio of basketballs to footballs? Every ratio can be written in 3 ways. The first way is 4 to 6. First quantity to the second quantity. The second way is by using the colon. 4 colon 6. First quantity and the sign or the notation of colons, then the second quantity. Third way, we will write it as a fraction. First quantity divided by the second quantity. Be careful. Order matters in a ratio. So 4 to 6 is not the same as 6 to 4. Now we will solve another question. Write the ratio of sandwich to Coke bottles in 3 different ways. How we will solve this? First, we have to know the number of sandwiches. 1, 2, 3, 4, 5, 6. And number of bottles. 1, 2, 3, 4, 5, 6, 7, 8. So the ratio of sandwich to Coke bottles is 6 to 8. We can write it in 3 different ways. The first way we are using the colons, and the second way we can write it as 6 to 8, and the third way by using a fraction. Since a fraction can be simplified, we can simplify the ratio 6 over 8 to 3 over 4. The ratio of a sandwich to Coke bottles can also be expressed as 3 colon 4 or 3 to 4. Now, how to simplify the ratio? We have this question. Simplify the following ratios. First one, 4 to 8. And the second one is 10 to 8. And the third one, 8 to 10. Step 1. Write the ratio as a fraction. Second step, simplify the ratio, find the greatest common factor, GCF. Remember, when we say the greatest common factor, it's same the highest common factor. So the highest common factor for 4 and 8 is 4. So I divide both the numerator and denominator by 4. 4 divided by 4 equal 1. 8 divided by 4 equal 2. Step 3. Write the equivalent ratio in the same form as the question. So the ratio is 1 to 2. Compound ratio. What's the meaning of compound ratios? A ratio that compares more than 2 quantities is called compound ratios. For example, a cake recipe says that the ratio of cups of milk, sugar and butter are 1 to 4. So this means that there is 1 cup of milk for every 2 cups of sugar and 4 cups of butter. Now let's practice together. You have 100 different shirts. The ratio of blue to black shirts is 20 to 30. A. Write the ratio of blue to black shirts in 3 different ways. B. Write the ratio in simplest form. C. Explain what this ratio tells us. Solution. You have 100 different shirts. The ratio of blue to black shirts is 20 to 30. A. Write the ratio of blue to black shirts in 3 different ways. First way, I will write it as 20 to 30. The second way, I will write it by using the column 20 colon 30. The third way, I will write it as a fraction. B. Write the ratio in simplest form. How we will simplify the ratio? We said we simplify the ratio like we simplify the fraction by finding the greatest common factor. So here we find the greatest common factor for 20 and 30 is 10. So 20 divide 10 equal 2. 30 divide 10 equal 3. So the ratio in simplest form is 2 to 3. Explain what this ratio tells us. This ratio tells us for every 2 blue shirts there are 3 black shirts. Now we have this question from your course book, page 137, question number 6. Brian is drawing a scale diagram of a building. For every 10 meters of the building, he draws a line 5 centimeters long. Brian thinks he is using a ratio of 2 to 1. Alan thinks Brian is using a ratio of 200 to 1. Is either of them correct? Explain your answer. First here, what's Brian doing? He is directly write the ratio 10 meters to 5, then he simplify it, divide both on 2, divide both on 5, he get 2 over 1. But this is wrong. Why it's wrong? Because he didn't convert the meter to centimeter. When you want to write a ratio, first you have to convert meter to centimeter. That means you have to make both units same. So I will convert now 10 meter, I will convert it to centimeter. 1 meter equal 100 centimeter. And 10 meter, that means equal 1000 centimeters, because I will multiply 10 by 100. After I convert the meter to centimeter, now I can write the ratio because both units are same. So the scale is 1000 to 5. Here, after I write the ratio, I will simplify it. How I will simplify it? By dividing both sides by 5. How much I get? I get 200 to 1. So what do you think? Who's correct? Yes, Alam is correct, because when he wants to write the ratio, he directly converts the meter to centimeter, while Brian, he directly writes the ratio without converting. So Alam is correct.